Limits, day 2, part 1. Here we go. So I need a reader. Thank you so much, Ava, for volunteering. Go for it.
When evaluating a limit, the technique you always want to try first is direct substitution. If a limit cannot be found using direct substitution, then we'll use other techniques to try and evaluate the limit. Keep in mind that some functions do not have limits. If direct substitution yields 0 over 0, otherwise known as
Indeterminate
form, then you cannot determine the limit in its current form. Encountering this form means you should try another technique. One way to deal with limits in this form is to use algebraic techniques like factoring, simplifying, and rationalizing the numerator.
All right, fantastic. So what do we try first every single time?
Factoring.
No, what do we try first every single time? We did it yesterday. Direct substitution. That's what we try first every single time. And if we get 0 over 0 or a number over 0 or something like that, we have to try other techniques. All right? All right, you know what? Let's put them out. All right, what's the limit? When you do what? Approach from both sides arbitrarily close to a number, a y value number. That's what a limit is. Does it have to touch?
No.
Can it touch?
Yes.
There's 4 reasons a limit doesn't exist. 1,
It's an endpoint.
Increasing
jump discontinuity. 2, increasing and decreasing without bound. 3, oscillating. And 4, endpoint. All right, so let's look at this example 3, this first one. So I have a limit as x approaches -1 of this function. So what do we try to do first? Substitute in -1. So what happens? 2 plus 1 minus 3 over 0. So I get 0 over 0, don't I?
Yes.
So what is that called? It's called an indeterminate form. So we have to do something else. Now, what do we like to do to quadratics? We like to factor them. So let's factor it. All right, so let's factor this numerator. So what does it factor to? 2x minus 3, and then x plus 1. Guys, I'm going to teach you a little trick. I'm going to be canceling out x plus 1, so guess what it's going to be? It's going to be x plus 1s. All right, so I need a 2x minus 3, and that would give me that quadratic. So the x plus 1s cancel, so that's cool. All right, remember when they cancel, a 0 over 0 creates a what? A whole. It creates a whole. So now I have a simpler function. The simpler function is 2x minus 3. It's the same thing as what we originally started with, except x equals -1. So now we substitute in -1 in my simpler function. So what do we end up getting? -5. So my limit of my original is -5. What's actually happening is I have a whole at -1 comma -5. That's really what's happening. However, does the limit exist?
Yes.
Yes. All right. But does the value exist? No. All right. Let's look at part B. So I have this one as the limit of x approaches 3. What do we try to do first every single time? Substitute in. What do I get? I get 2 minus 2 over,
3 minus 3.
which is 0. So I get 0 over 0. So I get an indeterminate form again. And this is where people kind of like don't like it too much because they feel like it's wrong. I'm actually going to rationalize it or unrationalize it. So right now I have this square root thingy, but I want to multiply essentially by 1. So I'm going to multiply by square root x plus 1 and then plus 2 over the square root of x plus 1 plus 2. What did I just multiply by? This is a word that starts with a C. Conjugate. I multiplied by the conjugate. All right, but essentially I'm multiplying by 1. So let's work with the numerator first. So I have square root of x plus 1 times square root of x plus 1, which is just x plus 1. And then what happens to my middle terms? What happens to my outers and inners? They cancel out, right? So that's why we do the conjugate. And then -2 times 2 is? -4. All right. So then on the denominator, I have x minus 3 quantity times the quantity square root of x plus 1 plus 2. And I highly recommend you don't try to FOIL that, all right? Because something lovely is about to happen. What is my numerator actually?
X minus.
It's x minus 3. How about that? All right, so guess what happens? My x minus 3's cancel. So now I'm left with my simpler function. So I have limit as x approaches 3 of what? What's my placeholder up top? 1 over the square root of x plus 1 plus 2. Now, what do we get to try to do? Substitute in. So now I substitute in 3, and what do I end up with? 1 over 4. So my limit of my original function is 1/4. What really happened is you have a hole at 3 comma 1/4. That's really what's happening. All right, let's keep moving. All right, on part C, I have a limit as x approaches 0 of this. All right, I like to call them fractions. They're really called complex fractions. So what do we try to do first every single time? Substitute in. Guess what happens? We get 0 over 0. All right, so now we have to try something else. And I'm going to help you out. We're going to distribute dividing by x. All right, so now I end up having this limit as x approaches 0 of 1 over x times x plus 4 minus 1 over 4 times x. All right, do you see how I just distributed dividing? Now, how do you add or subtract fractions? What do you need? You need common denominators. So what does this first one need? I have x plus 4, I have 4, and x. So what does this first fraction need? A 4. It needs a 4. So I'm going to multiply that one by 4 over 4, because I'm essentially multiplying by 1. You see how I'm just making common denominators here? All right. What does the second fraction need? X plus 4. So I'm going to multiply by x plus 4 over x plus 4. See how we did that? All right. So now let's start simplifying. 4 times 1 is? 4. Minus, and then I have 1 times x plus 4, which is the same thing as saying x plus 4. Over 4 times x plus 4. All right, so we found those to be common denominators. Now, this is where students mess up sometimes. What do we need to do here? What do we do with that negative? We need to distribute that negative. So we're going to distribute that negative. And honestly, that's where people mess up right there. All right? Because what happens to the 4s? They cancel out. They cancel out. So that's really cool. And then I have negative x in my numerator right now. Well, can anything else happen? Okay, I could bring out a negative 1. All right, but right now I end up having this negative x over 4x times x plus 4. We can actually cancel out these x's. All right, so now I'm going to cancel out those x's. And so what am I left with? Is I'm left with limit as x approaches 0 of what's up top now? Negative 1 over 4 times x plus 4. All right. So now this is my simpler function. So now when I substitute in 0, what do I end up getting? Negative 1/16. And then we're done. All right. So that really has a hole going on at 0 comma negative 1/16. All right. Pretty good? All right. What do we try to do first every single time? Direct substitute. So what do I get on the bottom? I get 0 on the bottom, right? Do I get 0 up top? I don't know yet. All right, so let's try it. So now I end up having 12 and then plus 10 and then minus 2. All right. So did I get 0 up top? No. What did I get up top? I got what? I got 20 up top. So I got 20 over 0. Now, what is 20 over 0? What is a number over 0? It's a vertical asymptote. So does this limit exist? No, it doesn't. This limit does not exist. And what is my reasoning for a vertical asymptote? It doesn't exist because why? It increases or decreases without bound. All right. And we're going to get more specific when we do these problems. All right. Pretty good? All right. Let's keep moving. All right. So now those are our techniques of doing it with direct substitution and then if we have to factor, if we have to rationalize, if we have to deal with a complex fraction. So now let's talk about things with this one. This is a very famous one. You're going to get this on the first day of limits in calculus. All right. So I have a limit as x approaches 0 of sine x over x. All right. So I'd like to graph this in our calculators. Go ahead and get your calculators and let's graph it. All right. So what do I try to do first every single time? Direct substitute, right? So if I substitute in 0, what's sine of 0? 0 over what? 0. So I get an indeterminate form. So at 0, it doesn't exist. However, that doesn't mean my limit doesn't exist. All right, so I need to go a little bit from the left and a little bit from the right. So let's do second calculate value. All right, like negative 0.01. Let's just do the middle 4 if you're cool with that. And what do I get? 0.99998. All right, and then if I go a little bit closer, we'll do second calculate value, negative 0.001. And then we end up with what? 0.99999. How many nines? 6 of them? 98. All right. And then I'm going to guess it's symmetrical. I'm just going to guess. Is it symmetrical?
Yeah.
All right, so then we get 0.9999998. And then we get 0.99998. All right, so what do you think the value of my limit is? Limit as x approaches 0 of sine x over x is what? What is it going to? It's going to 1. Now, will it ever reach 1? No. But it approaches from both sides. Where should the bridge be? It should be in the middle there, right? It should be going to 1. Does that make sense? Now, this is one of those that I actually can't prove to you guys too much until we get to like the end of calculus, all right? However, this is one that we just have to know, all right? So you just kind of have to go with this. So if you have a limit as x approaches 0 of sine x over x, we're going to say that is 1. Now, I proved it without using calculus by a table and a graph right now, okay? So later I can actually prove it algebraically, but we actually have to know calculus before that happens, all right? So that's what we're going to be using for these examples, and I think they're pretty cool. So let's look at this first one. I have a limit as k approaches 0 of sine k over k. Well, that's the same thing except different variables. So what's my limit? It's 1. All right. Pretty good? All right, cool. All right, let's look at part B. So now I have a limit as x approaches 0 of sine of 5x over 4x. Now, I have a sine of 5x. So I want 5x on the bottom. Does that make sense? All right, because I want just a variable. So I want 5x on the bottom. But if I do that, I still have a 4. But what do I need up top? I already had my x there. So what do I need up top in my numerator? I need a what? If I already put a 5 in the denominator, math and equal opportunity sport, I also need to put a 5 where? In the numerator. So I just manipulated it like that. You see how that worked? All right. So then I have a limit as x approaches 0 still. What does sine of 5x over 5x as x approaches 0 go to?
1.
That part goes to 1. So now I end up having a 5/4 times 1, which is 5/4. So I end up with the limit is equal to 5/4. Now, I know some students will try to do this, and I will not give full credit. I'm going to have this on a quiz and a test. and you might get your point for your answer. However, in calculus, the answer is only worth so much. All right, it's actually the process that they look at. So I know some people are going to want to pull out that 5. That's illegal. Is everybody hearing me on this? All right, you cannot say 5 sine of x over 4x. Is everybody hearing me? Will that give you 5/4?
No.
Yes, it will. It will give you the answer. However, when you show your work, you must do it this way. Does everybody hear me? All right, cool. All right, let's look at this next one. I have a limit as x approaches 0 of sine x over 5x squared plus x. What do we try to do first every single time? Substitute in, right? So what do I get in my numerator? 0. What do I get in my denominator? 0. So I got to do something different. All right? And that's where we need to manipulate this to get a sine x over x going on. All right? So what could I do to my denominator?
Factor on x.
I could factor out an x. Beautiful. So now I end up having sine of x over x times 5x plus 1. Love it. All right? So I'm just manipulating the way it looks. All right? So here we go. So now, what is the limit as x approaches 0 of sine x over x? What does that go to?
1.
That goes to 1. So now I have 1 times, now I substitute in 0 here. So what does that go to? 1 over 1. So what's my limit? 1. So that whole limit is just 1. Pretty cool?
Yep.
All right. All right, so finding limits. Homework algebraically. All right. Yeah, get going.